Hi, I'm Danish, and I am a part-time PhD student at IIT Delhi. I'll be describing my work on answering recommendation and comparison questions. Whenever we are about to book a holiday or travel, we have lots of questions. Things like where to stay, what to see, where to eat, and we will often take the help of travel agents who could then take care of our questions and travel needs. Or we may do some research online on the web, and sometimes even end up posting our questions on web forums in the hope of getting some precise answers from a fellow travelers. But the question I attempt to answer through my work is, can an AI system help answer questions that a traveler might have? But let's break this down a bit more. If you need to make flight and hotel bookings, you have a lot of options. You have online services that can help figure out the best flight and hotel combination, give you offers, and so on. But if you need specific tourism advice or suggestions, you are limited to time-consuming web searches. You need to refer to multiple blogs, maybe some travel articles, guidebooks, and so on. In fact, according to a 2019 report by Bain and Company, travelers make between 33 to 500 web searches before making bookings. Some users even consult in excess of 50 travel websites, spending a third of their online time conducting travel-related activities. Now, despite all this, if you don't find an answer, you may actually end up posting a question on a travel forum, and that again can take time. 31% of global travelers report wanting automated assistance to answer travel queries. Yet, at the end of the day, despite all the progress that we've made in AI, we are still unable to answer such questions. And that was the motivation for my PhD. I'll explain what I do in my thesis with some examples. Let's say this is a question that a traveler is asking, and I'll read this out loud. My husband and I are traveling to San Francisco with 3 daughters in their young 20s in October this year. Which would be a good hotel to stay near Fisherman's Wharf? Something not too expensive, but convenient to the majority of first-time visitors. We will not have a car, just using public transportation to get around. Any input for a first trip there, definite sights to see, we welcome. Now, let's say I have access to tens of thousands of reviews for hotels, restaurants, attractions, etc. And I also have access to their location information in terms of their latitude and longitude. In my work, I build methods that can reason over the question. For instance, from this question, aspects about a candidate answer hotel and its quality will be determined by reasoning over the review, whereas aspects on its location will be reasoned over spatial data. Finally, with joint reasoning over both reviews and spatial data, I get the names of entities, which is the name of a hotel in this case, as the answer. And the contributions I make to my thesis. This is the first QA system to answer real-world recommendation questions. It returns entity answers, and it does not require users to read web pages or blogs to figure out the answers. This work was demonstrated on 50 cities across the world, and I support 3 types of entities: hotels, attractions, and restaurants. This was a challenging problem. It required reasoning over spatial as well as textual constraints in questions, and then required understanding how to use knowledge in reviews and geospatial data to answer such questions. There's also a challenge of scale. Each city can contain thousands of entities, and my work required me to build methods that could process thousands of reviews, thousands of entities before answering any question. Now let's look at another kind of question. I will be traveling to Spain and then to the US for 2 weeks in the summer. I really wanted to visit Granada in Spain and also New York City, but due to some time and flight constraints, I will only be able to pick one of the two. Could you help me choose? Here, instead of seeking an answer, the user is looking to compare 2 entities. And this table is what I generate as an answer. The facets for comparison are generated automatically based on the pairs of entities being compared. And the table is populated by using phrases extracted from articles describing these entities. The table is a quick way of presenting comparisons. For instance, it's easy to see that New York does not have any old palaces. The key idea behind building this table is to use clustering, a technique in machine learning that groups related objects. And I introduce the concept of balance. Let me explain. Let's say I have phrases in some 2D space, where the phrases in red come from one entity and the ones in blue come from another entity. I could group them together like this. And you can see the table that it outputs the second cluster or group has information only from one entity. Or I could group them like this, where the information from both entities is more balanced. To summarize, in my work, I built the first end-to-end model for automated comparison. I extend machine learning methods for clustering to include the idea of balance. I conducted detailed user studies and found that users preferred balanced clusters and that they acquired as much knowledge by using tables as they did by reading the full articles, except that they required more time. Thank you for listening.